Hey, sorry, I was in my code challenge review.
You're all right. We're just getting started. So, hey everybody, and welcome to Advanced JavaScript. We got students from Mod 2 to Mod 6 in here, and I think we're going to do our darndest to make it very edifying for all of you. We'll do this probably a little bit more like study hall style. So Tiffany loaded up some questions for us to start with. First one is great. Differences between usage for callbacks, promises, and async await. So let's take a look at this. So all three of these are ways that we handle asynchronous code. Mod 2 students, you've done some of this also. You've done callbacks and you've done promises. So just so we have some examples in front of us, callbacks look like this. Something like some element add event listener. Click. So that's like a callback or a callback style thing. It's technically a handler, but same sort of format. Promises, actually, like, let's be clear about this. Promises are the underlying data structure. Like .then chains and async await both use promises, but a then chain would look something like fetch some URL, and then you do all these .thens, and then if something breaks, then we handle it that way. So that's another way we can handle asynchronous code. Async await uses the exact same data type and like fundamentally is kind of the same thing as these then chains, but instead of having this like chain of methods, we wrap it in what's called an async function. So like this is a regular function. Like that. The async await version of that just puts the async word in front of function. And now, since we put the async keyword in front of it, there's a special keyword we can use inside of this now called await. And it would work something like this. Response would be await fetch some URL, and then like parsed response await response.json const, and then we could do something like return Pokemons await parsed response dot whatever. And so that same code here would look like this. Call that parsed response. Cool. 3 different ways to handle asynchronous stuff, and it looks like this. Take a second to just kind of soak that in. We're going to talk more about it, but when we're dealing with something that doesn't happen right away, these are 3 different patterns for dealing with it in JavaScript. You even make the, hey, I'm going to make the examples match a little bit better. This isn't valid syntax, but it's the right idea.
Callbacks don't always have an asynchronous component to them, do they?
That's part of the definition of a callback.
Is it? Okay.
Yeah, so like things like map and filter and reduce, those technically aren't callbacks, but the syntax is the same.
What's part of the definition? Callbacks always have what?
An asynchronous part to it.
Okay, thank you.
They're happening in response to an asynchronous event. Let's see, parse. So if we were doing fetch with callbacks, it would look kind of like this.
Oh, is that because it's like callbacks are always an argument to another function, therefore they have to
Yes.
wait for that function to finish running before they execute?
That's not why, but they always do that, yes. And then this would be parsed. Then up here, this would be like get those Pokemons. Oops. And then this would be something like Pokemons. Okay, this is all like fundamentally the same shit in the 3 different ways you can do this in JavaScript. Take a second, just like soak that in. These are also chronological in terms of like when these patterns were most popular. Callbacks since like the beginning of JavaScript, then chains starting like 6 years ago or so. Async await starting like 3 years ago or so. All identical solutions.
I think I was asking about this before to somebody, but are .then and async await both kind of seen as being equally correct in terms of best practices out in the world?
Correct. I mean, be careful which bars you say that in. It's like they're opposite solutions to the same problem, and they're equally correct given a certain paradigm. Like, without being like too fussy about it, this is the functional way to do this. This is the OO way to do it. But you'll definitely see people saying like, oh, you don't have to use then chains anymore because we have async await. Like, I think async await's a nightmare. I'd way rather use a then chain.
Are they all just kind of doing like fundamentally doing an implicit wait for whatever the previous, I guess, like execution would be? I don't want to call it. I don't know what word to use.
Sure. You've got the right idea. So that's what this await word does, is like, don't go on to the next line until this is done. Don't go on to the next line until this is done. In this case, don't go on to the next line until that previous one is done. Don't go on to this until the previous one is done. If any of them have a problem, send it over here. And then for these ones, as soon as this is done, then I want you to run this function. And inside of that, whenever that is done, I want you to run that function. I want you to call back to this function and run that.
Cool. Okay. Thank you.
Really important part of this, though, is that those last two, I can't say this enough times, both of those are promises. You can even mix and match them. You can await a then chain. Two different syntaxes for working with the same data type. Cool. Ask me a couple more questions about these three different approaches for handling async stuff.
Would you say like, you say you like chains better, but
Correct.
would an async be better? Because technically, if your then gets a response, if it's not exactly wrong, it'll still move to the next one. So it doesn't really stop your code. But for the async function, if it's not right, it won't continue, correct?
No, those actually both work the same way. And I actually left something out of the async await example that is why I don't like them.
Okay.
Try catch. If I want this to be exactly like the thing above it, really what I need to do is try to do all of those things. And if any of them fail, I need to catch the error and do whatever I want to do with it. So that same code over here would be like that. The way promise chains work is if anything in that then chain breaks, it immediately jumps to the catch. Doesn't do any more of the thens. That's also exactly how this works. It tries to do this line by line. If any of them barf, it goes to the catch block.
Is it bad practice to nest try catches or like whatever the equivalent is in a different language?
I don't think you can nest try catches.
So I'm asking, and I know you might not have the answer. In Python, you can use try except with specific functions.
Yep.
And then you can nest them down so that, like, for instance, let's say your line, you don't actually have lines there, but if you're like, so your constant response, right? Like you could execute that and then below it do a new try. That way I'd be able to identify like where exactly it failed, as opposed to like with your current catch.
Oh, sure. You can, I mean, you would nest that. You would just do those one at a time, which is another reason why try catch is a stupid pattern. Because yeah, if I wanted to see exactly which one of those it was, I would do something like this. Now you can actually do that same thing with then chains. Hell of a lot more elegant. This catch will catch anything before it, and if it makes it past that, this catch will catch anything after it. Nothing breaks, the catch is never run.
Perfect. Okay, that makes sense. Thank you.
Yeah. But all of a sudden, that really clean, beautiful, doesn't have the ugly thens and stuff in it. Once you start actually using this, it gets a lot less pretty than that does.
Wait, so for it to catch exactly what you wanted to catch, you have to put it between every single await?
Correct.
Oh.
Yeah. Yeah, async await isn't so fucking hot now, huh? You hear that, internet? And so what you generally do is something like this. We go, all right, well, I'm just going to bundle all those together so that if any one of them breaks, I just have one error handler for all of them. But if I need to have 3 different error handlers, I need 3 different try-catch blocks. Cool. So let's talk about why we have 3 different syntaxes for solving the exact same problem. Start with callbacks. So the beauty of callbacks is that they really don't require any other, they don't need special data types. They don't really need much of anything. Under the hood, what this looks like, this function definition, would be something like, do this, check to see if it's done. While it's not done, keep checking. And then when it gets done, call whatever function got passed in. Super bare bones. It's been in JavaScript like since the beginning. Can anybody see what the problem, like why we didn't just do callbacks forever? You can start to see it here. If we had more things that chained off of this, it would continue to get worse. Can anybody tell what it is?
I mean, is it all of the curly braces and parens?
You're starting to get it. It has something to do with it.
Like all those returns, right? Like you're constantly returning like line after line, whereas like the dot then kind of encapsulates.
Yeah, and actually, it's not even returning too. It's an anonymous function, so it doesn't actually return. But like, yeah, if I had another thing on here, let's say I needed to fetch something with the Pokemon that I got back.
Keep going deeper.
Keeps going deeper. That sucks.
But
Yeah,
Kyle,
it just
I
keeps
love
going.
reading deeply nested things.
What was that?
But Kyle, I love reading deeply nested functions.
Nip. So we call this callback hell. Looks like that. Or that. Suck. So enter then chains. You have as many things depend on as many other things as you want. Stays flat the entire time. I've got more fetches I need to do. Fuck off, man. I can just then all day long. Beautiful. Now, it does still all run off of like one big long chain. And like, this is actually an example of a really specific functional programming idea called a monad, which was almost like perfectly designed to scare the shit out of new developers. And almost no other language, especially OO languages, do anything like this. And so, like in Ruby, like when you guys in Mod 1 did your like REST client things, you didn't have to .then stuff. All of that was asynchronous. How come I gotta all of a sudden handle all this asynchronous shit? So enter async await. Async await was created to make those people happy and gave them a very synchronous looking syntax that they could use. And it came with a pacifier and a safety blanket. Can you tell I don't really like async await? And it looks a lot more like this equivalent code would in Java or Ruby or most other languages. And the brilliance of it works with the same data type. It still promises.
Well, what's so scary about the MOAD for
Monads?
monads?
Holy fuck. Let's take a look at the definition. A monad is defined as a functor with additional structure. Let's see, what are the monad laws? It's lots of this kind of shit. And things like that. Like I said, almost like laser targeted at making people feel scared and inadequate. To fully qualify as a monad, these three parts must respect a few laws. So as long as your code respects these three laws, you can say that you made a monad. And like, obviously, any monad is a monoid in the category of functors. Actually, I thought it was in the category of endofunctors. And so that's why then chains scare the shit out of people. And here's the fucked up thing. It's actually pretty interesting stuff. And it's not nearly as bad as like they make it out to be, but there are definitely people who try to gatekeep programming by talking about category theory is what that is kind of generically called. And you don't need to understand any of it to use these things. Just use the patterns.
Are those the same people that think you have to have all of the algorithms memorized to be a programmer?
100%. Any other questions about callbacks, promises, async await, that sort of stuff? Cool. Let's talk about new things. Tiffany had unary operators. That's kind of exciting. Any other things you guys want to talk about? Or do you want to talk about unary operators? Cool. 3 different kinds of operators. An operator is something that operates on values. They come in 3 categories: unary, binary, and ternary. These names just refer to how many operands you pass into the operator. Off the top of my head, I can only think of 2 different unary operators. Not and type of, also instance of. So since it's a unary operator, it only has one operand. You are inverting the whatever binary thing that this evaluates to. You're returning whatever type a variable is, or you're returning whatever class something has. That's unary operators. Binary operators, we have like too many to count. And you've been using them your whole life. Plus, minus, multiply, divide. We're expecting 2 different operands on either side of those. So we call those binary operators. And there's only one ternary operator. Anybody know what it's called?
Ternary?
The ternary operator. So ternary operator evaluates a condition. If it's true, it returns that. If it's false, it returns that. It's a compact if-else statement. That's it. Those are your 3 kinds of operators. There's a lot of other binary operators too, but anything that you do that requires 2 operands, that's a binary operator. Other questions about operators?
Would like count or length be considered a unary operator then?
Nope.
I don't know exactly what's behind it. Oh, okay, cool. Thank you.
So something like dot length. Who can answer what dot length would be?
Method,
Method. Why?
because it's built into the class, so to speak, and it's just a function that lives on that class to return information about that specific instance of the class.
100. Very good answer, Bryce. So you're calling dot length on an instance of something. So you might have like a string and a method on the string class is length. So you can call dot length on it.
I guess
Actually,
I was
that's
just
not even a method. That's just a property. If you invoked it, like you have to invoke it in some languages because it calculates dynamically, then it would be a method.
so I guess what I was trying to think of is like like a property. What would a property fall under? Just a property itself?
Correct.
Okay, I was confused because like the type of the way I was thinking about that is that would work the same way as a property, wouldn't it?
Nope.
Okay.
Check it out. So if I open up a console and I do type of that, just an operator, doesn't depend on anything else. It is as low level as you get.
Okay, thanks.
Binary operator. Ruby doesn't have pure operators, by the way. That's like one of the 201 things about Ruby that is kind of cool. The way that this would work in Ruby is the thing that I just wrote is equivalent to that. It is calling the plus method on a number instance and passing in another number. I think that's kind of cool. Not in JavaScript though. JavaScript's got regular old operators.
Would plus plus or minus minus be a unary?
Oh, good call. Those are absolutely unary operators.
What about plus minus then? Because wouldn't that earlier plus equals minus equals, would that fall under
Yeah,
binary?
what would those be? Oh, I want everybody to think about that one. Plus minus, or sorry, plus equals, minus equals, times equals. What do you think about which kind of operators those are? I'm going to call on somebody. Alex Gabriel, what do you think?
I would think it's a binary
Why?
just because you have two what do you call it? Two things that you're comparing it to or want to operate on each
Yeah.
side.
Correct. Yeah, it's a binary operator. And the word you were looking for was operand.
Yeah. Would pipes and the and symbol that
Yep.
would be binary as well?
So yeah,
Or are those not
and
operators?
for like a logical and, it's binary.
Yeah.
That is a binary operator. Did you guys know that you can do the plus plus and the minus minus on either side of the number? It's kind of cool. So you can do something like let I equal 0, and you can do minus minus I, or I minus minus. Has anybody read what the difference is? It's super tweaky.
Oh, I literally just did. Hang on. Oh, well, go ahead.
Anybody know? So when you're using a variable like this, you're usually using it in something like an if statement or a for loop or in a function or whatever else. If you put it before, it mutates it down and then does whatever you're trying to do with that number or that variable. In this one, it'll evaluate, does whatever you're trying to do with that variable, and then change it. Most of the time, it doesn't make a difference, but every once in a while it does, and that can technically go another direction. Like right there, this returned -1, but that's not what I is anymore. It's -2, but it evaluated it first and then lowered it. This one, it lowered it from 0 and then read it.
When is this like, best use and worst case use too?
Like, don't overthink it. Like, you're going to go with this after 99% of the time. You tend to see this more in implementations of algorithms in particular. There are a couple situations where that can make your code a little bit more concise. But old functional Kyle over here actually doesn't like either of them. I'd way rather you use something like plus equals. Plus plus and minus minus are unnecessarily confusing for the reasons I just explained. Way easier to do something like that. And then, like, there's no plus plus or minus minus for something more than 1. So now you can also control by which amount you're incrementing something. Cool. Next question Tiffany had was, how does the inheritance model in JS differ from other languages? This is a huge one.
If you can talk about what prototyping means in JavaScript in an interview, it's huge points for you.
Absolutely. Is this the thing that like no bootcamp grad knows? Because it's really confusing. Here's a way to think of it. In Ruby, we did classical inheritance. Classical in this sense doesn't mean old. It means class-based. So when we do classical inheritance in Ruby, I have some big thing like a person. And then I might have a subset of that that's a student. And then I might have a subset of that that's like a hip array student. So a hip array student is also a student, is also a person. And so any like properties or methods that are here are also part of student. Student can add anything it wants to it. Hip array can add anything it wants to it. But all of these are like structurally one thing. You can think like you copy pasted all of the methods and properties from person and student into hip array student. Ask me questions about that concept of classical inheritance. God, I'm good at explaining things.
Wait, okay, I have a question.
Good.
Cool. So if you were to change a method in student,
Uh-huh.
would then hip hip array inherit that change but not person?
Correct. Person doesn't know anything about student. Student knows everything about person.
Got it. Okay, that makes sense.
Also, so these are the classes. If I have a person class, student class, hip hip array class, that inherits all the way down. I make an actual instance of it. It's just one thing that has all of those on it. That was the blueprint. This is the actual cookie. So in JS, we have prototypal inheritance. It's not prototypical, prototypal inheritance. And this same example with that would be a person object, a student object, and a hip hip array object. Same stuff though, each of them can have all of their own things on them. If you ask hip hip array student for something that it doesn't have, it goes, I don't have that. Does my prototype have it? And then it looks on student. Do I have a property or method with the thing you just asked for? Nope, I don't. Maybe my prototype does. Hey person, do you have any of these things? Nope, not me. Then it's going to look at the top level prototype, which in JavaScript is object. Go, hey, object, do you have a property or method with this name? Not me. Then you get an error. That's what a reference error is. It goes, I looked all the way up the prototype chain, couldn't find what you were asking for, man. But the big thing that's important in this classical model, we have these blueprints and then we make concrete instances of it. With prototypal inheritance, these are concrete instances. There is no blueprint. It's looking on regular old objects for these properties and methods. And where that gets wild is the blueprint's fixed. You wrote that as code and then you made instances of it. Since these are just regular old objects, we can change them while the application is running. Something could not exist on the student prototype at one point and then get added later in the program.
Is the looking at the prototype working in a similar way to like how scoping works?
Yes.
Okay.
So is it with the prototypal inheritance where you get that that problem referred to as like the gorilla holding a banana sort of issue?
That's the classical inheritance problem.
That's class. Okay, I've got to get my head around this because I keep on mixing up the two a lot.
So the gorilla banana problem is all I wanted was a banana. That's the hip hip array. But what I also got was the gorilla, which is the student, and the whole goddamn jungle, which was person. You probably only wanted something that was specific to this, but since it inherited from all these things, you got every fucking thing coming along with it.
But aren't there it seems like there's also, because I remember the way that you've talked about like class, like how class works in JavaScript, like how it's I feel like I remember you explaining that it's like a little bit of like a disaster to like
Yes.
avoid you can.
Can confirm.
So
So yeah, the class keyword in JavaScript is just sugar for this thing. It doesn't introduce classical inheritance, but people from OO backgrounds were doing all kinds of gymnastics to replicate classes, like class-like things in JavaScript. And so they just made a keyword that made that seem like you were doing classical inheritance. It's still prototypes under the hood. So the equivalent concept to a class is a prototype. And a prototype is just an object, like a concrete object. So you go, I would like this to be my prototype. And now you can use all of its methods and properties.
Where exactly does that gorilla holding the banana problem, like how does that manifest as like as a problem in development? Does it lead to like really expensive network calls or just really expensive operations when you're trying to get something from an inherited method that's far up the chain or
Sure.
outside the container, I guess?
The bigger problem is that inheritance works really well for these kinds of contrived examples that we talk about in school, and not at all in real life. In real life, things don't fall into really neat taxonomies like this, where hip hip array, student, person, easy. Then you go like, okay, but somebody who's in hip hip array is also an instructor of another cohort. Ooh, well, that taxonomy doesn't quite work. That's the gorilla banana problem.
So it seems like the recommended way to deal with that in both types of inheritance is just to avoid the inheritance altogether and just make new models.
You are correct. Inheritance is largely viewed as a mistake in programming. Cool. There's a couple like examples. A really good example where inheritance, I think, just fucking rocks is in Rails. The way that things like controllers and models work. You have a base model that has all of those cool active record methods and shit on it, and you can inherit all of those from in your specific classes.
So it works really well with like inheriting kind of like broad general class models that work well within the frameworks that they're
right. And also very shallow. They don't go very deep.
I'm sorry, what was that?
Also very shallow. There aren't very many layers to like good inheritance.
Gotcha.
So if like it sounds like, so you said using inheritance is just in general a bad idea. It sounds like it would totally fuck up your database relationships. Like if you're, depending on the size of it. So like based on your like your student instructor example, right? So for instance, like if you have a student person cohort person, right? And they're trying to pull them over as a, well, I guess not necessarily.
This doesn't have anything to do with databases.
Okay, sorry, I my bad.
Like it's this isn't relational data modeling. This is object data modeling, which is like an opposite way to show how things are related. And this is what things like active record do, is translate between those two layers or two different styles.
Okay.
So let's take a look at this in action, because there is one place in like your budding careers where knowing about prototypes kind of comes in handy. Actually, let's do it this way. I want to do a round robin. Let's see how many like JS data types we can come up with off the top of our head. So music, why don't you kick us off? Give me any JavaScript data type.
Like a Boolean?
Yep, Boolean is one of them. Gerald, give me another one.
An array.
Array. Arrays are
Object.
not one of the data types. Thank you for throwing it out there, though. That's exactly why I want to do this. Bryce, try to give me another one.
String.
String is one. TJ, give me another one. You're muted.
Is it number in JavaScript?
Correct. There are no other numeric data types. Actually, that's not true as of 2021. There's one called big int. You'll never use it. Yeah, there's only number. Other languages will have float and double and like all kinds of other numbers. JS just has number. Nate, if you're there, is there any other JavaScript data types you can think of? Nathan Gusky? I'm gonna take that as no. Jack, give me another one.
Symbol.
Symbol, thank you. Also very rare. I doubt that any of you will use symbols anytime in the next 2 years. Paige, can you give me another one? Getting harder.
I feel like is there something for like either like, is it like undefined or null or something like that? Like, isn't that a weird JavaScript thing?
Look at Paige just wrecking shop over here. Both of them are basic data types. All right, Brooke, there's one more. Do you know what it is?
No, I can't think of any.
All right. Kat, Augie, throwing it out there. We've been talking about him for the last 20 minutes.
Starts with an O, right?
Correct.
Oh, object?
There we go.
Is an
So,
array a type of
what was that?
object? I said, is an array a type of object?
Yes, exactly. So we'll call, other than array, we'll call all of these primitive types. They are, they're not objects. They are just values. That's it.
What about null?
Object, what was that?
What about null?
Even no.
Null,
It's an
okay.
object. Just a value. Objects, this is where all the magic in JavaScript ultimately comes from. So object is our top level prototype. Everything ultimately rolls up to object sooner or later. Things that have object as a direct prototype, array. That means array has some of its own things, like you can't map an object. So that gets added in with this. But there are things that we can do with all objects that you can also do on arrays. Because when you do something like array dot keys, I don't think that's even defined on the array prototype. It's defined on the object prototype. So when you do whatever your array is dot keys, looks to see if the array prototype has it. It doesn't. So it looks up the chain to see if object has it. Function. Function's also a kind of object. Promise. Also a kind of object. Node list. That stuff you get back from like query selector. It's not an array. Doesn't come off of array. Comes off of object. It's very array-like. It has some of the same kinds of things on it. At the end of the day, though, it descends off of that. And these will have whatever your array is, whatever your function is. Whatever your promise is. Mira. All right, so I do something like sum array 1, 2, 3. Neat. Let's take a look at sum array. All right. These are the things that are on the array that I just made. It also has a length of 3. Oh, but what's this? It has a prototype. And the prototype is the array prototype. So what does that give me? Oh shit, it's all of the array methods. So when I do sumarray.map, it's going to look on this and go, dog, you don't have a map. Your prototype does, though. If I asked for something that wasn't on this prototype, well, what's your prototype? It's object. So if I ask for has own property, it's going to look up the prototype chain until it finds that function. And what's wild about that is that these things, once you write them, it's done. You have your concrete instances. Like you can't change the blueprint while the program is running. Not so in JavaScript. In fact, watch this. So toString. My array didn't have a toString method. Does the array prototype have it? It does have one. And then this one has one too. So that's how you override stuff. So that has a toString method, and then the array itself has one. Now, if I do array.prototype.toString equals a function that just console logs some string. And I go with some array.toString and invoke it. So while the program is running, you can hack those things.
So you change the number array to a string?
No, I called a method that already had a definition, and I changed it real time. I can do the same thing with map. You could say array.prototype.map, instead of being whatever it is now, is something that takes in an element. I'm not going to make it complicated. Cool. So now I'm just going to take my little array that I made, and I'm just going to map through it real quick. I'm going to do all the things that I normally do, and why is it being so mean to me? That's prototypes. They're not blueprints. They're actual things, and you can actually change them while the application is running. The really practical thing for you is understanding this, that arrays are not a primitive type. Node list, array, function, promise, all of those roll up to object. They're peers. And your instances of those are also in this prototype chain. And so when people talk about mapping in JavaScript, like if I looked this up, array.prototype.map, that's why they use that prototype word in there. Because it's not your array, it's on the array prototype that all of those have in their chain. Also, I don't know if you like put all this together yet. Function is an object. Really? So if I did something like, I make a function called say hi. Cool, so there's my function. I can call it. I can do all the things that we do with functions. It's also just an object. So you can put values on it. You can put other functions on it. You do whatever you want with it. Just an object. It also has a prototype. It's the function prototype. That has all these things that we can do with all functions. That has a prototype. It's object. Same as everything. Pretty cool. There's some like really cool advanced shit that you can do with using the fact that you can store properties on functions in JavaScript. Not important though.
So at an interview,
yeah,
what about this would we really need to take away? Like I'm not sure like where they would go about asking us a question about this.
Sure. So in an interview, I would say it's pretty reasonable to ask somebody, what's the difference between classical inheritance and prototypal inheritance? So you'd need to be able to like recreate and talk about these two diagrams. When you do classical inheritance, a hip array student is a person, and they're all kind of jammed together in one thing. Prototypal inheritance, this object references this object, references this object, references this object. If I ask for something that this doesn't have, checks to see if its prototype has it. If it doesn't have it, checks its prototype, and ultimately we'll check the object prototype. If it couldn't find that property or method on any of those, if I do say hi dot Kyle, there's no property or method by that name. Oops. Yeah, it's undefined. Shoot, how do I do that? There we go. It's not a function because undefined isn't a function.
This feels like a really dumb question. So when I'm just trying to get my head around this. So like in prototypal stuff, so it's like when you create an instance, it's almost like every single one of those methods is being defined in that moment, so you have access to it rather than being like pre-written and it is separate to it, or not?
Oh no, you're right there. No, that's not what happens, and that's the cool thing about prototypal inheritance. In classical inheritance, everything gets copied over, and so every object has a copy of all of the methods or whatever from its entire inheritance chain. In prototypal inheritance, it doesn't have a copy of those things. It looks up and actually calls it on that other object. So hip array student doesn't have students methods or persons methods or objects methods. If you try to ask it something it doesn't know how to do, it asks this object to do it instead. It didn't get a copy. Classical inheritance, it got a copy. Not so with prototypal. And here's like, you'll see this in performance hacking in JavaScript sometimes. Let's say I'm making a giant fucking list of 10,000 things. I got an array of 10,000 objects on it. Every single one of them has the same 3 methods. Okay, now I've made 30,000 copies of the same method. That's dumb. It's super inefficient. So what I can do instead is give them a shared prototype that has that method. Now there's only one copy of that method or one copy of that property or whatever. And when I ask the one little list item, here I can draw it. So all these little things here, if there's something that they all need to share, I can put this in their prototype chain and put all the shared properties and methods on this prototype. That keeps these a lot thinner, which means they run faster. That's another super strong use of prototypes.
What would that look like?
That would look like I make a function like, I make an object like shared object and it'll have a method called speak. Call it dog. All right, cool. So, or shoot, let me do that one. I'm gonna add a property to it too. Okay, so there's my dog object. Let's say I have a whole bunch of individual dogs, like const Bixby, const Mesa, whatever, all these other dogs. So what I can do is, there's like there's a couple different syntaxes for this. So I think this is it. I can say your prototype is dog. And now if I do Bixby.speak, shit, that wasn't it. Let's see, JS set prototype. There we go, set prototype of. There it is. All right, so I've got that. I've got Bixby. I do Bixby set prototype of, not a function. I could have sworn it's something like, oh, it's actually, it's a static method of object. So it'd be object.set prototype of Bixby to dog. There we go. So now if I do Bixby.speak, looks up the prototype chain.
Does that work in Node as well as browser JavaScript?
Yep, that's a JavaScript thing, not a runtime thing. Yo, Bixby, how many legs you got? But when I look at just Bixby, there's nothing even on the object. I look at its prototype and its prototype. Cool. Last questions before we break. Cool. Hopefully this was interesting at a minimum. Cool. Thanks for letting me hang out with you. See you at stand down.
Thanks, Cal. That was awesome.